So today we're going to cover surface area of prisms and pyramids. It's an addition to chapter 11. This is usually taught in a pre-algebra course, and usually 7th grade math or 8th grade math. But the reason why I just want to quickly go through it with you and just spend one day on it is this will show up on an SAT or an ACT. So it's going to be important that you understand how to find the surface area of these solids. Technically, as long as you know the basic formulas, you can just go ahead and do each face separately and add them up. And that's probably what they taught you in middle school. What I'm going to show you today is if your solid, your prism or your pyramid is a regular solid, then we've got a shortcut formula that we can use. So the first thing, though, that we're going to do is define what lateral area is and what surface area is. The lateral area is going to be the sum of the areas of the lateral faces. So if you recall back when we talked about prisms, you had a base, which is usually like the top and the bottom. But again, remember, your solid doesn't always sit on the base. It's whatever shape you have two congruent faces of. All the other faces are called the lateral area. And it's sort of like if it were sitting on its base, it would be the sides. The surface area or the total area of your solid would be just adding up all the different faces. So in the case of a prism, you would have two bases and then all the lateral faces. In a pyramid, you would have one base and then all the triangle lateral faces. Now, abbreviations that you're going to be doing when I'm going through the examples. For lateral area, I'm just going to refer to that as LA. And then surface area. Some books call it surface area, or other books call it total area. So I might refer to it as a TA. So the formula to find the lateral area of a prism is going to be the perimeter of the base times the height of the prism. For the total area of the prism, that will be the total lateral area plus 2 times the base area, where the capital B is going to represent the area of the base. And again, lateral area will be perimeter times height. Now, in the first picture that's here, this first solid up here at the top, this is a rectangular prism. And we learned how to name them earlier in the chapter. Now, for the rectangular prism, this is the only solid where you could actually choose which rectangle you want to be the base. In this case, I would probably say the base is going to be the one that it's sitting on. But you could have also named the base to be either the left side or the right side, or the top and the bottom, or the front and the back. This figure that's over here, notice this one is not sitting on its base, but the shape that you have two congruent figures of, we have two congruent triangles, and then 3 congruent parallelograms, which would make this a triangular prism. And then this shape right here, notice all the congruency marks, making this a regular hexagonal prism. So if you're given pictures of prisms or pyramids where it's a polygon base, then we're going to go back to that lesson where we learned the formula for area of a polygon. And remember, that was that formula 1/2 apothem times perimeter, or the 1/2 ANS. So we're going to be bringing back this formula when our base shape is, say, a hexagon, or an octagon, or a pentagon. Again, I probably will not give you questions on the quiz where you're going to be doing trigonometry. we'll just be doing our special right triangles and Pythagorean theorem. So again, in my picture here, so again, these are the formulas. So perimeter is the capital P and the H is the height. So lateral area is found by finding the perimeter of the base times the height of the prism. For the total area, I would find the area of the base shape, multiply it by 2, and then add that to that lateral area. So let's go ahead and let's look at our first example. Our first example, this shape is a rectangular prism. And just like I said before, you can choose which rectangle is your base. I'm going to go ahead and just use the base that it's sitting on, or the rectangle it's sitting on. So my base shape here is a rectangle. It's the 4 by 2. And again, this is 2 and this is 4. So this is my base down here. And then again, you'd have another congruent rectangle up here at the top. Remember that when we're calculating the perimeter, we needed to add up all of these numbers. So the 4 plus 4 plus 2 plus 2. And that's the first box that it's asking me to fill in. The capital P, this is where they want me to fill in the perimeter of the base. And that's found by adding up all the sides, giving me 12 centimeters. For the base shape, the capital B represents the area of the base, and my base is a rectangle. So I can either do base times height or length times width. So 4 times 2, and it's 8 centimeters squared. For the lateral area, we just learned this formula. It's the perimeter times the height. The perimeter of my base, we just found that in the top box, that was 12. And the height of my prism, that's the 6 here. So the 6 is the height of the prism. So 12 times 6, 72 centimeters squared. Now remember, for lateral area, if you would have rather found the area of each one of those 4 rectangle sides, you can do that as well. Just calculate each one and then add them up. And now for total area or surface area, that's going to be 2 times the base area plus the lateral area. Well, I found my base area to be 8, so I'm going to do 2 times 8 plus my lateral area, which is 72. 2 times 8 is 16. 16 plus 72. And my total area for my rectangular prism is going to be 88 centimeters squared. Now, probably back in middle school, you weren't taught this perimeter times height for the lateral area, and then add in the base. What they probably made you memorize is something like this. 2 times the length times the width plus 2 times the width times the height plus 2 times the height times the length. Some kind of long formula like that. You can still do it that way. Basically what you're doing is finding the area of, say, the top and the bottom. And then here could be the left and the right side. And then this one could have been maybe the front and the back. Again, just realize that you have 3 sets of congruent rectangles here. So you could still do it that way if you choose for the rectangular prisms. But I think it's a lot easier if you see it's a rectangle base to just do perimeter times height and then double the base. All right, let's look at the next example. It's actually a triangular prism. And this time it's actually sitting on its triangle base. I know it's kind of hard to see here, but let me trace over the lines. So I've got a triangle base here. So the top and the bottom are triangles. Notice they gave me the height here. It's 2.8. And then the base, so this would be the base, and this is the height. And again, I could add the 4 here for this side. So for the perimeter of the base, my base shape is this triangle. So I'm going to add 4 plus 4 plus 3. And I get 11 centimeters for the perimeter. The base shape is a triangle, and that formula for area of a triangle is 1/2 base times height. My base of that triangle was 4. The height was 2.8. Once I multiply those three numbers, 5.6 centimeters squared. For the lateral, and again, this 6 that's here, this is the height of the prism. So for the lateral area, I'm doing pH. And again, I already calculated the perimeter up at the top. It was 11. And then the height is 6. So 66 centimeters squared. And then for total area, when it's a prism, 2 times the base area plus the lateral area. And again, my base was 5.6. My lateral area was 66. 2 times 5.6 is 11.2. I'm going to add 11.2 and 66, giving me a total area or a surface area of 77.2 centimeters squared. So the triangles are the bases. The lateral faces are those parallelograms or those rectangles. Now, in this particular example, everything is given to me to find the area of this hexagon. If it weren't given to me, I'd have to draw in the radii, find the measure of the central angle, pull out the special right triangle, and then go from there. However, what was nice here, again, it's not sitting on its base. However, the base shape is a hexagon. So again, this is a hexagonal prism. And to find the area of the base, I need to do the 1/2 ANS, or remember you could also do 1/2 apothem times perimeter. Either way, in my figure here, the 6, this is the height of the prism. It's not sitting on its base, but if you tilt it down, the 6 is the height. The 8, this is the side length. So this is S of my hexagon. The 7 in the picture, that's my apothem. So notice I have everything I need to plug it in to get the base area. Now, if you want to do perimeter first, then we could use this formula. Perimeter, remember, is number of sides times the side length. Number of sides in a hexagon is 6. The side length was 8. So the perimeter is 48. And no units on it, so just units. Now, if I want to just use that now in my base formula, all I have to do is 1/2. My apothem is 7 times 48, which is the perimeter. And my base area is going to be 168 units squared. Now, notice it didn't ask me for total area. But the reason why I did all of this first is, remember, your formula for total area is 2 times the base area plus lateral area. So now, remember, lateral area, I can go ahead and calculate that down here. Remember, is perimeter times the height. I just found the perimeter to be 48, and the height of my prism is 6. So my lateral area is going to be 48 times 6, which gives me 288 for the lateral area. And now I can take this number and then times this one by 2, and that's what's going into the formula. So 2 times 168 plus that lateral area, 2 times 168 gives me 336, plus 288 gives me 624 units squared for my total area or surface area. They both mean the same thing. So again, if you go and take the time to find perimeter and base area, then to find total area, it makes it a little bit easier. So these were the prisms. Now we have pyramids. So again, 2 methods to find the lateral area. Now, when it's a pyramid, these lateral faces are going to be triangles. Now, these formulas that are here only work when it's a regular pyramid. So in the case when there's 4 triangles up there at the top, it has to be a square base. If it's an equilateral triangle as a base, then you can use these formulas. If it's a rectangle base, then we would just have to find all of the faces separately and add them up. And we're going to do that on the last example. So 2 methods here. You can either find one of the triangle faces and then multiply it by however many triangles you have. So if it's a square base, you'll have 4. Or the second method is to multiply 1/2 perimeter times slant height. Notice in my picture, I've got 2 different heights labeled on my pyramid. I've got the actual height of the pyramid, which goes from the vertex down to the center of the polygon base, or the pyramid base. And then I've got the slant height that runs along the side of the triangle. That's going to be the height that we use for the lateral area. If I were calculating volume, then I'd actually need that height that goes through the middle. Let's go ahead and see the formula now for total area, and then we'll do an example. So the formula for total area, just like before, instead of 2 times the base area plus the lateral area, now there's only 1 base when it's a triangle. So really it's just B plus LA. But here they've already filled in what LA is. It's the 1/2 perimeter times slant height. Now notice down here at the bottom it says, if the pyramid is not regular, then all we have to do is find all of the faces separately and add them up. Okay, so for example 4, it says that we have a regular square pyramid and it's giving us a base edge and a lateral edge. Now notice this is a different label than what we've seen. So let me go ahead and show you where the lateral edge is located. So let me go ahead and draw my pyramid. So I've got a square pyramid, and it says all of the base edges are 6 centimeters. So all these edges down here on my square base are going to be 6. Then it says it has a lateral edge of 5 centimeters. So that lateral edge they're referring to is this edge right here. Now, in order to use the formula for lateral area, I need to find the length of the slant height. And remember, the slant height goes from the vertex to the middle here of the base edge. Notice I've just formed a little right triangle here. I'm going to pull that out. Now this slant height actually bisects the 6. So this side is 3 now, because I got 3 and 3 here. And then I've got 5. So to find the slant height, which is L, I'm going to be doing Pythagorean theorem. Now, if you recognize that this is that classic 3, 4, 5 triangle, then you don't have to do Pythagorean theorem. But I'm going to do L squared plus 3 squared equals 5 squared. L squared plus 9 equals 25. Subtract the 9. L squared equals 16. Square root it. And my slant height is 4, which is the first question. So the slant height equals 4. And again, the slant height is always indicated as an italics letter L. Remember, to find the lateral area, we can either find each one of the triangles, and in this case, there's 4 of them. And once we find the area of one of them, times it by 4, or we can use that shortcut formula, which is the 1/2 perimeter times slant height. The perimeter of my base, each one of the sides are 6. So 4 times 6, the perimeter is 24, times the slant height, which I just calculated to be 4, giving me a lateral area of 48 centimeters squared. And this lateral was a centimeter, and then this is 48 centimeters squared. So that's one method. The other method to find the lateral area, I'm going to find one triangle face, and then I'm going to times it by 4. So if I just did the 1/2 base times height for one of the faces, the base was 6. The height was that slant height I just found. So the area is going to be 12, and then times it by the 4, and I get 48 centimeters squared either way. So you could do it either way. Just find the area of one of the faces and times it by however many you have, or do the 1/2 PL. Now, for the base shape, so for part C, my base is a square. So it's just going to be 6 times 6, so 36 centimeters squared. For part D, it wants total area, or again, sometimes it's called surface area. So remember, that formula is going to be area of the base plus the lateral area. Well, I already found the area of the base. That was part C. And my lateral area was part B. So let me just plug those numbers in. 36 plus 48. So my total area is 84 centimeters squared. Now, let's say they wanted us to also calculate volume of this pyramid. And that's why part E is asking us to find the length of the altitude. So remember, the altitude is going inside here. And let me get a different color. So the altitude is actually the height of the pyramid. And again, remember, it goes from that top vertex into the center of the base. Notice what I can do here is now draw a segment that would go over here to the side, which would be half of the 6. And now what I'm going to do is make a special right triangle here using that slant height. So for part E, let me do E up here. I'm pulling out, this is the altitude or the height. I know that this is 3, and I calculated the slant height to be 4. Now, at first glance, you're thinking, oh, it's a 3, 4, 5, But remember, the 5 would have needed to be the hypotenuse. So I actually have to do Pythagorean theorem here. H squared plus 3 squared equals 4 squared. H squared plus 9 equals 16. Subtract the 9. H squared equals 7. Square root it. And the height, or the altitude, is going to be square root of 7 centimeters tall. So that's how you would do part E. And you would have done that just in case they ask you to find the volume of that pyramid. Or let's say the given information was the height, and then we needed to calculate the slant height. Then we would have needed to do Pythagorean theorem to get the slant height. So again, we're bringing back a lot of our triangle information when we're doing these figures. We have 2 more examples, and then we're done. Still a regular pyramid in example 5. This time it's a regular triangular pyramid. And notice they gave me enough information to answer part A, because they gave me the slant height already calculated. So this slant height comes down here, and that's your L, and it's 9. So in order to find lateral area, all I have to do is 1/2 perimeter times slant height. So it's 1/2, 12 times 9, and that gives me 54 centimeters squared. Now, the base area, this is where I got to work for it. It's a regular triangular pyramid, so this tells me I've got an equilateral triangle for my base. And I know that the perimeter is 12. So that tells me each one of these sides here on my base are going to be 4. So let me go ahead and pull this base out. And then I'm going to work with it in order to find the area of that triangle base. So here is my equilateral triangle, which is the base. They all have a side of 4 because 4 plus 4 plus 4 is 12. Now, as soon as I draw in my altitude, remember in an equilateral triangle, all 3 angles are 60. So now, as soon as I split this by drawing in the altitude, it turns it into a 30, 60, 90. And we knew this was 4. This one got split. It was 2 and 2. So now the height of my triangle, remember you're memorizing these sides to be, this side is x. This would have been 2x, and this is x root 3. So 2 square root 3 is the height of the triangle base. So for the capital B, 1/2 base times height. My base is 4. The height is 2 root 3. So the area of my base is 4 square root 3 units. No, they were centimeters. Centimeters squared. So that's my base area. It's 4 square root 3 centimeters squared. So remember, total area, it's the base area plus the lateral area. So the base area was 4 square root 3. Lateral area was 54. If it asks you to leave it exact, you would leave it like that. If it says round to the hundreds place, this is where we need to use the square root button. And then once we do that, we get 60.93 centimeters squared for total area. So notice the base here is a rectangle. This one is a rectangular pyramid. It is not regular, so we cannot use the formula. What we're going to do is find all of the faces separately and add them up. So what we're going to be doing for total area, we're going to find the area of the base, and then we're going to find the area of the front triangle plus the area of the back triangle plus the area of the left triangle plus the area of the right triangle. So the left and the right, they're going to be the same. And then the front and the back will be the same. So like the front, we could say maybe is this one here. Or actually, let's do this one as the front. And then this could be like left and right. And then across from it is going to be the same. So that would be left and right. And then same thing here along the back. We would have the pink one. So for the area of the base, it's a rectangle. So we're going to do 11 times 5. For the front triangle, remember it's a triangle, so it's 1/2 base times height. So my base is 11 and the height is 10.3. And I've got that twice. And then the left and the right would be the 1/2, 5 times 11.4. And I got that twice as well. Now, if you'd rather do it once and then times it by 2, you can do that. I'll go ahead and multiply all of this. Gives you 55. The front and the back is going to give me 56.65. And then the left and the right, 28.5. I'm going to add up all these numbers. And the total area for this rectangular pyramid is 225.3 yards squared. And that is it for this little supplement on surface area.